All right, so today we want to talk about conformational analysis. Conformational analysis. All right, so what is conformational analysis? Well, let me give you an example. If I was to take butane, all right, and I was to rotate this bond, okay, I could draw it in this format here, where it now looks like that. Now, if I were to show the hydrogens, we can see that the hydrogens on each end, so when we say carbon 1 and 4, so let's call this carbon 1, carbon 4, are now in closer proximity to one another. All right? So if I were to draw my hydrogens here, so here's a hydrogen, hydrogen, hydrogen. Let's make these red, so hydrogen, hydrogen, hydrogen. All right? So these are going to be hydrogens. And my blue hydrogens are now over here. Notice that now we have this interaction here, all right? And this interaction is higher in energy than this interaction over here, right? So higher energy, right? Just from the rotation of the sigma bond. And these molecules freely rotate. All right, so what we usually use to identify this is what we call Newman projections. So Newman projection. All right, now, if I were to draw a Newman projection, you typically draw them, and some people like to call them a Mercedes-Benz symbol. Right, however you want to draw it, however you want to think of it. All right, and what this does is this allows you to put your eye down a carbon, all right? So if I was to imagine putting my eye right down this carbon here, so let's label these carbons. That's 1, that's 2, 3, 4, all right? So this would be 1, this would be 2. You can think of the back one as 3, and then this one would be 4. We want to look and see what's attached to each one, all right? So attached to carbon 1 is a CH3, right? So that's the blue CH3s, all right? On each side is a hydrogen, right? So this hydrogen here, and this hydrogen, 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 right? 3, there's another hydrogen, right? So here's a hydrogen, here's a hydrogen. And then on the back, we got our other CH3. So this is the most stable, all right? And this is what we call anti, all right? Now, there's many conformational analysis, all right? And so what we can see is if we rotate that bond 60 degrees, all right? So this is the rotation I have shown here is 180, but let's say we start out with a 60 degrees rotation. So if I rotate this 60 degrees, and I'm actually going to start over here now. So let me redraw my Newman projection. All right, so if I start, and I rotate 60 degrees, so I'm going to rotate the front, okay? So we're going to rotate this right here 60 degrees. All right, so I'm going to leave my back the same. Go ahead and draw what's there, CH3, hydrogen, and hydrogen. All right, rotate 60 degrees. Get a little bit better circle here. There we go. It's always hard to draw it like this. All right. Our CH3 is now here. Our hydrogens are now here. And you can see that these groups, right, are now eclipsing one another. And so this is what we call eclipsed. All right. Now, if I was to rotate another 60 degrees, all right, so let's say 60 degrees more. Come back, draw my Newman projection. All right, now it's going to look the same. The back, again, is going to be the same. And now the front's going to be the same, similar looking as we start off, right? So our CH3 is in the back, our red one. All right. And then we have a hydrogen. Remember, the back's not changing. Now we have hydrogen here, here, and our blue CH3 is here. So now these two groups, our biggest groups, are now 60 degrees from one another. And this is what we call gauche. All right? So gauche is actually lower in energy than the eclipsed. So lower lower energy than eclipsed. All right. Now, if we were to rotate another 60 degrees, all right, so another 60 degrees, we draw another Newman projection, all right. Again, back stays the same. We're only rotating the front. All right. Let's see if I can't make that look a little bit better. There we go. Now, our CH3s are right next to one another. And our hydrogens are right next to one another. So again, this would be eclipsed. All right. Now notice that this Newman projection here represents this compound here. All right. Now, if you were to continue rotating another 60 degrees, you would start going backwards now in this direction. So the next one would be gauche. So what would happen is these groups here would basically switch. So this one and this one here. So now this would become CH3, and this would become a hydrogen. Right? And then your groups again here would switch. As you would have hydrogen, CH3, and then hydrogen, until you get reverted back to your original one, which is called anti. Now, let's look at a actual drawing of a energy diagram. So if I had an energy diagram, energy is increasing in that direction. All right. And if I were to plot these Newman projections, I would get something like this. right? Where this is 0, this is 360, right? So this is anti. This would be eclipsed, gauche, eclipsed, gauche, eclipsed, and anti. All right.